99. What's 99 says? What's 99 says?
X cubed plus 3x squared minus x plus k, and then there was an x minus 2.
X minus 2 is a factor?
Yeah.
I don't think this is in the division. Okay, I think I did this question, the SAT question on previous day. Okay, so if x minus 2 is a factor, that means you can divide this polynomial with x minus 2, and the remainder will get 0. Remember that question that we did? It was the exact same question. It just, that question is written in SAT. This question is written in this. This is not remainder theorem. This is understand remainder theorem connected factor theorem. Okay, we're going to talk about what's factor theorem today. But if you have x minus 2, that means if I want to long divide this, this is going to be positive 2 or negative 2. Positive 2, good. And that's going to be 1, 3, negative 1, k. But the result is going to be 0. But I don't know what that is, so I'm going to drop the 1, 2, that's 5. 5 times 2 is 10. That's 9. 9 times 2 is 18. And then k plus 18 is equal to 0, so k must equal to negative 18. And that's the SAT question there for you. Next question. Matter of fact, oh yeah. Matter of fact, I did a question yesterday. It's harder than this SAT. But it's not gonna show up on SAT, but this will. Yeah. Huh? If it's a factor, that means you can divide it by x minus 2. But if I divide it by x minus 2, it's in that division. I change that negative 2 to positive 2 anyway. So, yeah. Did I answer your question, Brendan?
Yeah.
Okay, next question. No other question? No graphing questions? Yes.
97.
97? What's 97 says?
2x to the 4th plus x to the 3rd minus 3x squared plus 2x. And then it's e of negative 4 for us all.
What is it?
E of negative 4.
So this is a v of x, I assume? Oh, that's f. Did anybody say that? Oh no. It's, I think so. Oh, p. Okay, so p of negative 4. Good. Okay, so this is a question that will trick you, and this is a great question. Did you see there's a placeholder? A lot of you guys don't see it. That's actually a placeholder on a constant rather than thing. So they are placeholders. So 2, 1, negative 3, 2, and 0. There's a placeholder. And then this is negative 4. This is what you're supposed to do, Ian. Huh? Yeah, no, the signs stay the same because the remainder theorem just plug in exactly the same. And morning, Ian, there was probably 6 or 8 of you guys. I just don't remember the name of it when I go around to check your homework. You cannot evaluate using the things because I will tell you use the remainder theorem to evaluate. So that's going to be 2, negative 4, negative 8, negative 7, 28, 25, negative 100, negative 98, negative 98 times 4. I have no idea what that is. 3 what? 392? Positive, right? So the 392. So the answer is 392. Simple as that. Nothing crazy. Something that I think most of you guys can manage. Is anybody who's friend with Cohen? Tall,
Colvin.
huh?
Colvin.
Huh?
Huh?
Tall white kid.
Colvin.
I know Colin.
Michael.
Cohen? I haven't seen Cohen for a while,
Yeah,
right?
no, I know.
In school or just this period?
In
In general?
general.
Do you know if he's sick? Because last time I talked to him, I think I saw him missing a week. Okay, I gotta call him. What happened? 392. Is that okay? Okay. So let's talk about one of the graphing questions. So somebody can tell me which graphing question then you help. Which one? Number one. Okay, so what is the question is?
F of x equals negative x squared, and then parentheses x minus 1 close parentheses x to 3.
X plus 3. Okay, really good. So we're gonna start today like going through this because I did it at the end of the period. A lot of people don't have no idea what's going on. So for this type of question, you can find the basic informations. M behavior is 1. So M behavior. And the second one is x-intercept. Actually, y-intercept. I'm gonna start with the y-intercept. X-intercept. Multiplicity of the x-intercept. Multiplicity, it just means how they behave on a particular x-intercept. So let's just say, let's start with M behavior. Okay, the M behavior is, so Merlin, were you here yesterday? Okay, what can you tell me about M behavior yesterday? What do we talk about? How do we, what's the part that decide M behavior? Well, yes, that, but which I'm more like talk about which part of equation that determine that M behavior is in this functions. It does. It does. That's one relevance. There's another one. Yen, can you tell me?
Whether the exponent is even or odd.
Good, but what is that term called? Yes.
First term.
The first term. What does that usually call in math? You're right, the first term. Yes, Armin?
Leading coefficient.
Leading coefficient. So the leading coefficient is the one that decides it. So what I'm going to do is I don't want to multiply every single thing out because that's going to take a while. And that's going to take like 2 minutes for you, and which is I don't want to do. So I'm just going to extract the terms. So let's say negative x squared. This one just x without a 1, and this one just x. So it'd be negative x to the 4th. This, and then there's a dot, 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 dot after that. We don't care about what happened after that. We only care about what's leading coefficient, negative x to the cube. If this case that look like it's like, okay, well, that looks like the easiest graph I can think of that have similar degrees and similar coefficient in the front is what? Negative x squared. That is same thing of that on the chart. So therefore, x squared look like this, and therefore as limits as x approach to negative infinity, always start from the left, always make sure you write it properly, is equal to negative infinity. Limit x approach to right of f of x is equal to positive infinity. So that's just the way it is. Oh, sorry, not positive infinity, negative infinity, I lied. Okay, so, well, that means both sides going to go down. Y-intercept. Well, y-intercept, that means what? Where's y-intercept at? X equal to 0. So f of 0, always plug in 0 for x, right? So that's going to be negative 0 squared times 0 minus 1 times 0 plus 3. It doesn't matter. That's just equal to 0. So 0, 0 is the y-intercept. X-intercept. X squared equal to 0. X equal to 0. X minus 1 equal to 0. X equal to 1. X plus 3 equal to 0. x is equal to -3. Now let's write down the multiplicity. Multiplicity for -3 is what? Multiplicity is 1. Why is 1? Because this is 1. Multiplicity -1, that's also equal to what? What's multiplicity here? 2. So that just means that's how they behave. At 0, oops, my bad. You guys gotta be not afraid to graph. I know certain individuals are very afraid to graph. I know, like, there are some of you guys. I think Arias is afraid to graph. I think Emerson might be afraid to graph. I don't remember, but some of you guys are afraid to graph something. Go ahead and graph it. And most of you got it wrong. It's no big deal. Yes. What?
Like, can there only be one x-intercept?
There's 3 x-intercepts. There's only one y-intercept. Can they have multiple y-intercept? No. Because that won't be a function.
So how do you determine the multiplicity the -3?
-3. Okay, so I look at here. I look at the degrees, which is the exponents. This exponent is 1. This exponent is 1. That's going to help me. The exponent is the multiplicity of that 0. So if I say x plus 3, so I set x plus 3 equal to 0, x minus 3, and I look at the degree of that parenthesis that's giving me that 3, -3, and then I say the degree is 1, so therefore it's m equal to 1. Does that make sense? Yeah. Okay. So now I'm going to go ahead and graph it. And at -3, I'm going to write down the multiplicity because that helped me determine how the graph's going to go. 0, m is equal to 2, and at 1 is going to be m equal to 1. Now, I'm going to go ahead, always graph the m behavior in there. So if I graph this here, and I know that in general at n, it's going to be what happened here. So m equal, so this is gonna go from down here. It's gonna go through them like a spear. M equal to 1 is like sphere. And if I go to here, I'm gonna come back to that 0. But this is m equal to 2, so it's gonna be a bounce. It's parabola depends on where the parabola come in. If you come in from the negative side, it's gonna be a negative parabola. If it's from the positive side, it's gonna be a positive parabola. So in this case, it's gonna be a positive parabola, and it's gonna go down here. And that's the graph it's going to be. Now you can have x cubed graph. You can have multiplicity of 3. That is going to form a waterfall at that particular point. Now, some people ask, hey, how high is this part of the graph go? I have no idea. I don't really care. I only need to tell me, like, what do they behave on the x-intercept and how do they behave? If you graph that, then that's going to give me good enough information for make sure all the things. Yes.
But it's possible.
Is it possible? Yeah, you can plug in the value. Well, you can plug in that value. Yeah, like I said, but that's not the point because I don't want you to spend a lot of time on that. Yeah, it's possible. Yes.
What if the x-intercepts and the multiplicity of 4, would it do like the same thing as here?
Yes. So to show you that the x to the 4, so x squared, that's look like this, right? And to the 4th, it just looked like this. To the 6th, it just looked like that. It's not changing. It's flatter. The more value it goes, the more flatter because the value is going to go up faster. If you go into 100, it's going to look like this. It's almost look like a straight line. And it's going to go to, let's say 2000, then you're going to see exactly like there's not even like any value. It's going to go up a little bit. But the next value is going to go crazy. So at 1 is already be 100. Yeah, so at 1, 1 to the 2,000 power. 1 to the 2,000 power is still 1, but 1.01 to the 2,000 power becomes like astronomical. Because if you do 1 here, it's still 1. But if you do 1.1, but 1.01 is not going to show. At 1.1, it's going to be like crazy amount of number. Okay, did I answer your question? Okay, so let's try to graph this function and let's see if you guys graph it right. Now this is the first time I'm going to give you to the third power. The third power look like a waterfall. So x minus 3. Okay, so I want you to graph this. Now again, I want you to find all the information. I want you to find those 4 information. M behavior, y-intercept, x-intercept. So 1, 2, 3, 4. M behavior. Graph it by yourself first, and then after you're done, check with each other. So M behavior, x-intercept, y-intercept, and multiplicity. Sorry, this one should be y. I always do y-intercept and x-intercept and multiplicity of. So remember, something to the third look like an XQ graph. Multiplicity of a 0. 0 is also not a name for x-intercept. By the way, 0 roots x-intercept. That means exactly the same. The y-intercept is value is kind of high, so you can just scale that a little bit. No, you don't have to grab all. You don't need to count exactly. I don't know. 108 squares. Just kind of estimate where is it. Just write down 108. Hopefully you got 108. Is 108? It's probably negative. Julia, check with. Check the right on the cell phone. Emerson, check with Austin. Happy to help you or Kayla.
I have like points, but I don't think I got it. It's supposed to be. I don't know if it was bounce. That's gonna be over here on the x-intercept. Since you made this an vertex, it just had the negative here. So you go down. You can go down to 3. And then you go up.
All right. Let's check this graph. The end behavior is gonna be what? Well, what's the leading coefficient here? Negative x to the third times x squared. What is x to the third times x squared? X to the fifth. Good. So it'll be negative x to the fifth. The easiest graph you can think about is odd and negative is gonna be the y equal to negative x. So this side is gonna go up, this side is gonna go down. So your in behavior should be limit x approaching negative infinity of f of x is equal to positive infinity. Is that okay? Limit x approach to positive infinity of f of x equal to negative infinity. Did anybody got this part wrong? It's okay. Just let me know, at least I know. Anybody got this part wrong? You did? Did? Okay, that's fine. So where were you guys confusing about, Emily and Lena?
I just meant on like the shape, like it was supposed to go this way.
Okay, so think about, do you know what the negative x graph look like?
Yeah.
So it's the same thing because that's odd degrees, right? X is odd degree, x to the 1, and negative. So just think about the simplest graph you can think about. That chart is for you to see whole thing, is you don't have to memorize something that's very complex. Lena, do you... Why do you think it's even one? With x to the third times x squared, why is that even? Did you got x to the 6? Okay, then why you think about the even if it's 5? Okay, no, that's okay. I mean, this is that's the process of thinking that you got to think it through yourself. Has anybody got it wrong and have misconceptions? It's okay. So Emily told me that she just confused that certain part. That's fine. Because right now it's okay. Y-intercept. What's the y-intercept? You can plug in 0 for x. That means y-intercept. So it'll be negative 0 minus 3 to the third, 0 plus 2 to the second. That's equal to minus negative 27 times 4. So that's equal to... Wait, is positive 108 or negative 108? Oh, my fault. Negative, it's positive 108. So 0, 108. X-intercept is what? X equal to negative 2. So x plus 2 equal to 0. X minus 3 equal to 0. X equal to 3. So multiplicity is what? for 2 is what? 2. What's the mode of C for this one? There you go. And like I said, I'm gonna estimate that 108. 108, I'm gonna say is roughly, it's right here. It's 108 because each one's 25. And then at -2, it's gonna be 0. At 3, it's gonna be 0. But m is equal to 2. I'm gonna write down the mode of C on top of it because that way I know. And the m behavior is gonna be this side is up, this side is down. So the parabola, this part is gonna behave like a parabola because m equal to 2. It's gonna go up. It's gonna come back down. It looks like a waterfall. And there we go, the zero graph. How many of you guys got it right the first time? Okay, only not many of you guys. So we need to try one more. Is that okay? And then
If there were numbers,
no. Okay, so let me that's a good question. So I'm gonna put a 2 in front just for Merle. Now think about it. If you set that factor equal to 0, set 2 equal to 0, is that true statement? No, so that is not part of 0. So even I put 2 over there, it's not gonna be affect. If I put -2, it's gonna affect the m behavior, but it's not gonna affect anything else. So if I put -2 there, it'll be a more interesting question. But if I have two there, it doesn't have any bearing. Maybe it only affect the y-intercept. That's it.
So it would affect, if it was a negative sign, it would affect the m behavior, right?
Yes, but if it's a, yeah, if it's 2 only affect the y-intercept at most. It doesn't even have to because if it depends on what your factor is. And after you graph it, you gotta check with decimals. The next objective is, what if I give you the graph? Can you tell me the equations? But this is the next part. Ian, you finished graphing?
You want us to do it with 2 or no?
Yeah, just do it 2. Because that's gonna affect something in here. After you graph, please check with decimal, Jada. Check with decimals. Guys, some of you guys SAT score improved just because you knew how to use decimals, probably. And you didn't know that they allow you to use decimals on every questions. So learn how to use it. It's okay. You're gonna learn how to use TI-84 or TI-Inspire later, but I'm gonna teach you that. But once you know how graphing calculator work, everything is pretty much it translates. So learn how to use it. Your homework, you got to check every single time. Is your graph right or wrong? And it has a feedback system. Hopefully you know how to multiply the exponents. It should be x to the 6. Did you guys get x to the 6? It's true, x to the 6. 2 doesn't matter. So the 2 in the front doesn't influence anything. If negative 2 influence is going to be something. So here is going to be limits as x approach from the left side. Limit x approach to the right side. Again, this is equal to what? They both equal to what? Negative infinity, positive infinity, positive infinity, positive infinity, and then positive infinity. Leah, does that make sense? Because this is even, and this is positive. So even positive, think about x squared graph. X squared graphs look like this. Going to the left is positive infinity. Going right to positive infinity. But you need to multiply the exponent correctly. Liam, you okay? Do you understand? Got it? Okay. 2. Neo, can you tell me what the y-intercept is? It's probably pretty... What can you tell me y-intercept is? Is it 40? Okay, so it's 40. So it'd be f of 0. That means 2 times 0 minus 1 to the third times 2 0 plus square 0 minus 5. So it'd be 2 times negative 1 to the third times 4 times negative 5. It seems like that's going to give you 40. That's correct, right? See, I told you, you have to write the graph. You could just gotta graph it. As most you got it wrong. Yes.
Wouldn't it be negative 40 because negative 1 cubed is just negative 1?
Negative 1 cubed is negative. And then there's a negative 5 at the end, so it's negative. Okay, so those are the things you have to be careful and be really disciplined on what you're doing. 3. Y-intercept is what? Sorry, x-intercept is x equal to what? 1. X equal to negative 2, x equal to 5. Where's the multiplicity? 3. Multiplicity 2. Multiplicity is 1. So I'm going to go ahead and graph those things in there. Okay, so that is 1 is going to be 3. So m is equal to 3. I'm going to use the 2 spaces 1. And negative 2 is going to be, so this is negative 2, this is a 1. So m is equal to 3. And the 5. Okay, so 5m is equal to 1. So they are both going up. Draw the m behavior. And what's the y-intercept? 40. Wait, that doesn't make sense. It's true. Yeah, that's right. I was gonna say that doesn't make sense. So this one is gonna go 40. So it's gonna go here. Multiplicity is 2. It's gonna go up. It's probably gonna come back down. Draw like this. And its probably graph is gonna be like this. Yes. Yeah. Today you're gonna trial and error. Okay? So today, the last question before I leave is how do you go backwards? So I'm gonna ask you to come up with an equation that has this. This is at negative 1. And this is at negative 2. And something like this, sorry. Something like this. Hold on. That's 2 here. So I want to give you a graph that's something like this. This is -2, this is -1. Can you tell me equation of this graph? I don't have a lot of time, so I'm going to show you. First of all, there was some type of f of x here. So for this, what will be the factor here? What will be the factor of this one? Okay, so good. X plus 1. So that's going to be x plus 1. Why is it x plus 1? Because x equal to -1. Can I remove it to the other side? Come to x plus 1. Is that okay? What will be the multiplicity here? 2. So can I just write down 2? Is that okay? And what will be here? X plus 2 will be multiplicity that one. -2. Thank you. So what will be multiplicity of that one? 2. Now what you're going to do is, I don't know what's leading coefficients. We're going to assume that this is a. And I don't need to care about what is. I need to find out exact value too. I cannot just find out anything else. I cannot find out if they're positive or negative. In general, if you have this, it's great. But then you have to find out what a value A. What other things I can use? What? It might be negative, but what will be A is? A is actually a number, a very specific number. Yes, Bennett? Yes, but you assign this part as A, right? And you assign that A, and you want to go back and figure out what A is. Use the y-intercept. The y-intercept is 0, -2. So can I figure out -2 here and just plug in 0? So A is equal to what? -1/2. So if you do this, f of x is equal to -1/2. I don't know about any other part of the graph, but this graph should give you this as y-intercept at specific point. So I'm going to go in to graph this. What was the equation? It's -1/2 and what? X plus 1 square. X what? X minus 2 square. And look at this. Exactly like this. You come up, but A is the value you had to determine. You cannot just say they are positive and negative. That's not good enough. I want to actually find out the value of A. Okay, I want you to actually find out the value of A. So today, Jada, you guys gotta graph it and check on the decimal. Emerson, same thing. Katie, same thing. Go ahead and graph it and check on decimal and give you brain feedback. You need to have that feedback loop.
Like I finished it though.
No, you're supposed to finish at home.
I know, but I didn't have
I'm
time.
sorry.
I was doing it if you wanted.
Sorry. No, be fair.
You didn't catch it.
We lost. was trying to court me yesterday.
He was on thin ice.
He was
He was on thin ice.
Come on, though.
So there, wait, guys, for second derivative class, I'm still,
What's the last time you're on thin ice?
so like, if you're doing the number line test, how do you figure out what number? Like,
You know the things that say equal 0 get your x's?
so what, even if there's a numerator, there's a numerator and a denominator, and they both have factors, so I still use, okay.
Yeah, so
And then if it's like positive, like negative 1 and 1, I would still, those are the ones that use for the factor.
negative 1 and 1.
For like, for
I want to get the other.
We're so cute, bro. I need to.
Yeah, don't pick that one.
Sister doesn't even eat her cake.
It's gonna be a high score.
He's making the test as we
If I get over 45, that's a high score.
No. You're on thin ice, sister. Wait, how did it? What?
Yeah. So funny.
Dude, what? Backwards? What? Like, okay,
Roll start theorem is first derivative. Inside equals 0. And then mean dog theorem is find f minus f. Set that equal to the first derivative.
What?
B minus f. That equation b minus c or b minus n. And then you get that, then you set that equal to the first derivative. That's your answer?
What? Yeah.
So you're not even listening.
Shut up. I can't do
Nathan, you ready?
So when you get
you know what I'm
Great.
saying?
it's like the
It's
fraction.
like, if I have like 3 X's,
When you take the factor though.
if I put it, it was like 3
Oh, pick stuff off the top. Don't pick stuff on the bottom.
And bottom.
Don't pick stuff on the bottom. Only top. It's the
Because like minimum maximum you know that. Minimum maximum is 90. I feel like that's positive.
Wait, minimum is negative positive. Maximum is positive.
Look, I don't like if it's greater than 0 is positive. So if it's less than 0 is negative.
And if that doesn't even have like that's
Then F has relative maximum.
Yeah, because you're going literally going for out.
yeah.
I wonder how fast you are, Mr. Ray. Pretty speedy.
Huh?
Pretty speedy.
When I put it into that,
I've been going for it.
alright, you gotta get out of it away from each other. You listen with me? Okay. Stop being stupid. The pack is 3 pages.
What period are we in?
2 pages.
Small booklet. Small booklet. That what that is?
Yeah.
Stop on. Where'd you buy it? Stop on. Stop on. Just wait. We'll be done. You did jump it. Alright.
I did this.
Almost went through there.
Sorry. Ah, because you go back.
Oh.
Take your time, do it right. Enough time. There's a bonus question in the back.